Have you ever wondered why spilled water disappears after a short while? After heavy rain, everything outside is wet. Have you ever wondered how, after a while, it becomes dry all by itself? Or what happens to that water you splashed all over the bathroom? All of this occurs because of evaporation. Evaporation is the reason why pools of liquid eventually disappear. What actually happens is that the liquid slowly evaporates and becomes gas or vapor. All molecules of matter have energy. When this energy is increased, matter turns from solid to liquid, and then from liquid to gas. During evaporation, molecules at the surface of the liquid gain enough energy to break the intermolecular bonds within the liquid and fly away. This way, the liquid turns into gas and then disappears. So, evaporation is the turning of liquid into gaseous or vapor state from its surface without being heated. Now, what do we call the process in which we heat water or any liquid to turn it into steam or gas? That process is called boiling. Boiling occurs at a specific temperature, the boiling point of a liquid, and it occurs throughout the whole liquid, not just at the surface. This is why, during the boiling process, we see bubbles coming up throughout the liquid. Those bubbles are the same liquid turned into gas. Boiling occurs only at a specific temperature and throughout the liquid. So how does this compare with evaporation? Evaporation occurs at any temperature, which means that it doesn't necessarily need to be heated. Evaporation occurs because molecules gain energy. When we pour water into a glass, the water is still there when we come back after a few hours. So why doesn't it evaporate? Let's take a closer look. There are a few factors that influence evaporation. There's the surface area of a liquid. In a glass, a very small surface area of the liquid is exposed to the air. So evaporation in the gas occurs very, very slowly. However, in a puddle of water, because there's a larger surface area, evaporation occurs quickly. The greater the surface area, the greater the rate of evaporation. Another factor that speeds up evaporation is air or wind. Wind gives molecules more kinetic energy to enable them to escape from the surface of the liquid. So, the quicker the wind across a liquid, the greater the rate of evaporation. The temperature of the liquid also plays a role. The hotter a liquid is, the more kinetic energy its molecules have. This means that molecules at the surface will have more energy when the temperature is high, and therefore will need less energy to escape from the liquid. Therefore, the hotter the liquid, the greater its rate of evaporation. The nature of the liquid also influences the rate of evaporation. Liquids with lower boiling points evaporate a lot quicker and more easily than liquids with higher boiling points. The lower the boiling point of a liquid, the greater its rate of evaporation. Here's a fun fact. Do you know why you feel cool when your body is wet after taking a bath? The reason is evaporation. The water molecules on your skin take energy from your skin and evaporate into the air as water vapor. This means as the molecules use up the heat energy from your body to escape into the air, your body begins to cool down. So let's summarize. Evaporation is the change of state of a liquid into gas at any temperature on the surface of the liquid. Boiling is the change of state of a liquid into gas. However, it occurs only at the boiling point of that liquid and throughout the liquid, not just at the surface. The following factors affect the rate of evaporation. First, the surface area of the liquid. The greater the surface area of a liquid, the greater the rate of evaporation. Second, airflow. The quicker the airflow or wind over the surface of a liquid, the greater the rate of evaporation. Third, temperature. The higher the temperature of the liquid, the greater the rate of evaporation. Fourth, the nature of the liquid. The lower its boiling point, the greater its rate of evaporation.